Alright, so you got step 1 in torque down. Next step is equilibrium. Equilibrium is pretty easy if you get the first part of torque, which I taught in my previous video. So, the best possible scenario is when the objects are in equilibrium, because that means that all the forces add up to 0. So the net force is 0. So it just makes it easier because you don't have to worry about other numbers. So that means that the net force is 0, and since the net torque is equal to net force multiplied by r multiplied by sine theta, and if the net force is 0, that means that the net torque is 0 times r times sine theta. That means the net torque is 0. So the best possible scenario is when it's in equilibrium, because it's just easier problems to deal with. Alright, next. Okay, so just like the net force is F1 plus F2 plus F3, the net torque is torque 1 plus torque 2 plus torque 3. And if you expand that, that means that F1 times R1 times sine theta plus F2 times R2 times sine theta plus F3 times R3 times sine theta, and so on, is the net torque. So now let's apply this in a problem I'm about to give you. Let's say F is equal to 4, F2 is equal to 5, R1 is equal to 3. Hold up, I'm sorry about that. Give me a second. I'm so sorry about that. So F1 is 4, F2 is 5, R1 is 3, and I want you to tell me what R2 is. Oh, by the way, I meant -5. I just messed up. So let me write that, like, -5. Alright. So, you know that the net torque is 0, and that the thetas are 90, because I say that the thetas are 90 to make the problem easier. So, like I said before, the net torque is torque 1 plus torque 2. Let's say torque 1 is F1 times R1 sine theta. So it would be 4 times 3 sine 90, which is just 4 times 3 times 1, 12 Newton meters. Now torque 2 is F2 times R2 times sine 90, which is 5 times R2 times 1. Then that 1 just leaves it 5 times R2. And now, since the net torque is torque 1 plus torque 2, you substitute for torque 1, you substitute 12. And for torque 2, you substitute FR2. Then you plug that in, and you end up getting that R2 is -12 over 5 meters. Okay, no, excuse me. You end up getting that R2 is 12 over 5 meters, because since we had said that 5 was negative in the beginning, you get that the net torque is -5 R2 plus 12 is equal to 0. Okay, sorry about that. I am horrible with this app. But I hope you roughly get the idea. Alright, come on, I know you can get this. If you get this, that means that what I just told you before, even if you didn't get it, which I sort of understand because I spoke really idiotically, but whatever. If you can get this number 5, then you're set. So, 3 forces act on each of the thin square sheets shown in the drawing. In parts A and B of the drawing, the force labeled 2F acts at the center of the sheet. When considering angular acceleration, use an axis of rotation that is perpendicular to the plane of the sheet at its center. Determine in which drawing the translational acceleration is equal to 0, but the angular acceleration is not equal to 0. So, translational acceleration is just a fancy word for normal acceleration, the one that you've always been dealing with. Oh, my bad, my bad. Erase that, erase that. Okay, so let's start off easy. So let's draw A. So you got an F on each side and you got two F going in the middle. And it asks you, where do you think the translational acceleration is equal to 0, but the angular acceleration is not equal to 0? So this is the A drawing, right? This is where there's an F on each side and a 2F going up in the middle. If you have a force going up on the right and a force going up on the left, that means that there is no angular acceleration, because pretend you're driving. Let's say you have both hands on the side of the steering wheel and you decide to move both hands up. The steering wheel isn't going to move at all. So that means that your angular acceleration here is 0. But since the 2F is from the center and it's going up, that means that your acceleration is not 0. Alright, now let's draw B. That means that there's 2Fs going on each side and a 2F going down in the middle. So, same logic as before. If there's two equal forces going in the same direction on opposite sides of a steering wheel, there's not going to be an angular acceleration. So here, the angular acceleration is 0. And here, the 2F, it is going in the opposite direction of the two little forces. So they cancel out, and that's when acceleration is 0. And now, for C, let me make that easier for you to understand. So you got the 2F on the side, and you got F's on each side. So, if you have a steering wheel and you have both hands on each side and you pull down with both arms, there won't be an angular acceleration, right? Okay, that makes sense. But now let's pretend that your friend pulls on one of the sides up while you're pulling down. Since both of your arms cancel out the forces, your friend starts moving the steering wheel. That means that the angular acceleration does exist and it is not 0. But the angular acceleration is not 0, right? Angular acceleration is not 0. But the tangential acceleration, it is 0 because there is no force coming out from the middle. Yeah, I'm sorry, but I think you'll have to rewatch it a little bit to understand what I'm saying. I messed up a couple times with my speech, but you guys are an AP. You guys can get this. Okay, so now we're doing this. Okay, so a person exerts a horizontal force of 190 newtons in the test apparatus shown in the drawing. Find the horizontal force M that his flexor muscle exerts on his forearm. Okay, so first thing you gotta do is that you gotta know that your net torque is 0 here, right? Next thing you gotta know is your net torque, which is 0, is equal to torque 1 plus torque 2 plus torque 3 and so on. Now write down what you know, which is F1 is equal to 190 newtons and F2 is M. You know that R1 is 0.034 meters and that R2 is 0.054 meters. Okay, so you know that your net torque is 0 and that your theta is 90 degrees. That means that sine 90 is 1, so you don't have to worry about that. So torque 1 is equal to F times R, which is 64.6, and torque 2 is equal to F2 times R2, which is 0.054 M. You know that torque 1 plus torque 2 is 0. Now substitute for those two values, you get that. I'll just solve for M, and you get that M is 1196.3 newtons. And the reason why 190 newtons is negative is because it's pointing into the left direction. And that causes torque 1 to be negative. Alright, let's read this problem. So, the wheels, axle, and handles of a wheelbarrow weigh 60 newtons. The load chamber and its contents weigh 525 newtons. The drawing shows these two forces in two different wheelbarrow designs. To support the wheelbarrow in equilibrium, the man's hands apply a force F to the handles that is directly vertically upward. Consider a rotational axis at the point where the tire contacts the ground, directed perpendicular to the plane of the paper. Find the magnitude of the man's force for both designs. Okay, this sounds like it's a crazy problem, but if you really read into it, it's actually quite simple. First thing you want to do, at least in my case, is just redraw the drawing where it's more understandable and less cartoon-like. So you know that it's negative 525 newtons pointing down. You know that it's negative 60 newtons pointing down. And then now you know that F is positive pointing up. F stands for the man's arms. That's the little wheel. That little dot is the axis of rotation, and that's the line you want to worry about. And now the distances from the axis of rotation to that little red mark is 0.4 meters. From that red mark to that red mark, it's 0.2 meters. And from the red mark all the way to the right to the red mark I'm about to draw is 0.7 meters. Okay, the total length of the bar is 1.3 meters, right? Because 0.4 plus 0.2 plus 0.7 gets you 1.3. So the problem straight up tells you that it's an equilibrium. That means that your net torque is 0, right? That means that 0 is also equal to torque 1 plus torque 2 plus torque 3. Okay, so torque 1 is equal to the radius 0.4 times negative 525 newtons, and you get negative 210 newton meters. And torque 2 is equal to 0.4 plus 0.2, which is the distance, multiplied by negative 60, which gives you negative 36 newton meters. And then torque 3 is just 1.3 F, or the addition of all those distances. Alright, so you know your three torques, negative 210, negative 36, and 1.3 F. You know that your net torque is 0, and that all your torques added together is 0. You substitute in that equation to solve for F. Once you do that, you get that F is equal to 189.23 newtons, which is the force that the man uses with his arms. Alright, nice job, guys. You got torque down. If you have any questions, just rewatch the videos. If they're that hard to understand because of my stupidity from every now and then, just ask Mr. Burgos the next day.